Hello, my name is Amina Dasuki, and this is the video presentation for Chapter 5, Functions. Um, the main subject of study is rational functions, equation and inequalities. The topic for discussion that I have chosen is graphing of rational functions of the form f of x is equals to ax plus b over cx plus d. I want to really explore different types of rational graphs, so as to see how they are applied in real life situations. Rational functions are used to solve zeros and limits of a polynomial, and are a great way to engage students in the novelty of singularities. Real life situations. Graphing a rational function is applied to making certain types of ceiling bulbs or lights, like the one overhead. The lights that have the slope and the set of a certain graph of rational functions, so something basically like this. So that's the bulb here. And another bulb here. So basically the slope, having the slope. Basically what you will need is your graph paper, a pencil, and a pencil for this exercise, and of course place to show you're working. To begin with finding the vertical and horizontal, you begin with finding the vertical and horizontal asymptotes. There will be no oblique asymptote because the power of both x's, numerator and denominator, is the same. So you then go on to determine the domain and intercept of the end behaviors. After all of this, you then go ahead to plot your graph. So your example is given the function f of x is equals to x minus 3 over 2x minus 6. Sketch the function and determine where the function is increasing or decreasing. So your solution, and first of all, you start by determining the horizontal. Determine horizontal, the asymptote. So for the horizontal one, okay, you go x over x using the equation above this one. So x over x minus 3 over x all over 2x over x minus 6 over x. So your answer will equal, this will equate to 1. So 1 minus 3 over x all over 2 minus 6 over x. And this, when you work out your answer, as x approaches infinity, we have 1 over 2. So therefore, y is equals 1 over 2. So that is the horizontal asymptote. For the vertical asymptote, so the VA, your answer will be 2x. You make the equals 0. So 2x minus 6 is equals to 0. So your answer will be 2x. So your answer will be 2x is equals to 6. So x is equals to 6 over 2. So 2 here, 1, 2 here, 3. So x will equals to 3. You then go on to determine domain and intercepts. So the domain is equals to x. X is known as the element of all real numbers, so ER, but apart from when x is not equals to 3. So when x is not equals to 3. So your y-intercept, for your y-intercept, x will equals to 0. So y is equals 0 minus 3. So you're basically putting 0 back into this, the equation here. So 0 minus 3 over 2 times 0 minus 6. So your answer will equals minus 3 over minus 6. This will cancel out this, so this will be 1, and this goes into this 2. So your answer will equals 1 over 2. So you have another set of coordinates, so 0, 1 over 2, or half, or 0.5, sorry. For the x-intercept, y is equals to 0. So you make this, as this is this, so you make it 0 is equals to x minus 3 over 2x minus 6. Your answer will be x minus 3 is equals to 0. So your answer, you move the 3 onto the other side, so x will equals to 3. So you have another set of coordinates, 3, 0. To determine how the curve will move, determine how the curve will move. So your answer will, to the left of 3, taking the values to the left of 3, the f of x will still be positive. And taking values to the right of 3, x will still be positive. So for instance, if you put minus 1 into, so to the left of 3, as these are the negative numbers, so you'll go on to minus 1, minus 2, minus 3, 0. You put, so back into this equation, x minus 3 over 2x minus 6. If you make x equals minus 1, your answer will be minus 1 minus 3 over 2 times minus 1 minus 6. So your answer will be minus 1 minus 3 is minus 4 over minus 2 times minus 1 is minus 2, 6, minus 2 minus 6 is minus 8. So 4 goes into here 1, 4 goes into here 2, and then the minuses will cancel out the minuses, so your answer will equals to half, and it's still a positive number. And then values as well to the right of f of x will be positive as well. If you put any number into this equation, it will still be positive. We then go ahead to plot the graph, which I have done here. This is the line of x equals to 3, x is equals to 3, and y, as we work for our points, our coordinates, 0 is equals to 0, 1.2, 1 over 2 is there, and then 3, 0 is there on the graph. So I went ahead to draw the line where x is equals to 3 and y is equals to a half. You then go on to sketch the curve on this side, this should roughly be what it looks like, where the lines never touch basically. But on this side, so this is the decreasing value, and this is the increase. This is an increasing value. So the line has to touch the y equals 1/2. So it should go like this, but basically should never touch this one as well. So the way it goes this way, the way should go that way. So the curve is increasing over the range of minus infinity to 3, and decreasing over this range of 3 of the range of 3 infinity. Thank you. That brings us to the end of this video presentation. Thank you.